Sine, cosine, and tangent ratios, which is IB subtopic 5.2. So let's just jump right into it. If you've got an isosceles triangle, meaning that two sides are equal, sides AC and BC are each 7 centimeters long, and they each make an angle of 65 degrees with AB. So I'm supposed to draw a picture that represents this. So we've got AC, BC, and we've got triangle here. So that means that AC, B, these are each 7 centimeters long. And this guy is 65 degrees right here. We're supposed to find the length of AB, which may not be immediately apparent how to do that, but if you split this isosceles triangle right in half, then what you do is you create two right triangles. And what we could do is find this value of x right here using sine, cosine, and tangent, and then if we just double that value of x, we'll know the length of AB. So from the 65 degrees, that x is the adjacent side, and the 7 is the hypotenuse, which means we're going to use cosine. So I'm going to say cosine of 65 degrees equals the adjacent over the hypotenuse, x over 7. So to get that x, we're going to simply multiply both sides by 7. X is 7 times the cosine of 65 degrees. And that is just calculator work. Make sure your calculator is in degrees mode. Hit that mode button, put it into degrees, and type in 7 cosine of 65. That is going to give you x equal to 2.96. 3 significant figures. Now, that didn't really answer the question because we're still trying to find the length of AB, which means we need to double that x, so 2.96 times 2. And when you do that, you get that the length of AB is 5.92 centimeters after we double it. And then we're supposed to find the perimeter of the triangle ABC, giving our answer correct to the nearest centimeter. So we add these all up, 7 plus 5.92, and that comes out to 19.92 centimeters, but it says give it correct to the nearest centimeter, so the correct answer here is 20 centimeters. Okay, let's talk about another one. I want to talk about angles of depression. Find the angle of depression from the top of a cliff, 145 meters high, to a ship at sea 1.2 kilometers from the shore. So, here's a cliff. There's my cliff. And I know it's 145 meters high. And over here, across the sea, 1.2 kilometers away, there's a ship. First thing I notice here is that my units aren't the same. 1.2 kilometers is 1,200 meters. And we're supposed to find the angle of depression from the top of this cliff to the ship. So if I just connect these, I've made a right triangle here, but the issue is that most people want to say the angle of depression is right there. It's actually not. What you need to do is imagine that there's another right triangle going straight across here and here. The angle of depression is actually this one right here. That's the angle of depression. That's the one we're trying to find. So I'm actually going to be working with this right triangle up top. So this is still 1,200 meters, and this is still 145 meters. And I want to know this angle, let's call it theta. So from theta, we've got the opposite side and the adjacent side, which means I'm going to use tangent. So that means that tangent of theta It's 145, the opposite, divided by 1200, the adjacent. And we're trying to solve for theta, that angle of depression. So to get rid of the tangent, we just use the tangent inverse. So in the calculator, I'm going to type in tangent inverse of 145 over 1200. And we'll let the calculator do the heavy lifting here. Tangent inverse of 145 divided by 1200. The angle to three significant figures is 6.89 degrees. That's my angle of depression. All right, let's do another one here. Let's do the angle of elevation, which is always easier. Church spire, 81 meters high, casts a shadow 63 meters long. Find the angle of elevation. So let's say that here's a church spire, which is 81 meters. And it's going to cast a shadow, which is 63 meters. And the angle of elevation is the completion of this right triangle. It's the angle that's leading up here to the sun. So let's call that one theta as well. We're supposed to find that angle of elevation. Now from theta, the 81 is the opposite side and the 63 is the adjacent side. So I'm going to use the tangent again. I'm going to say tangent of theta equals the opposite over the adjacent. And much as we did in the previous problem, we're going to solve for theta by using the tangent inverse. 81 over 63. Once again, we're going to let the calculator do the hard work. Tangent inverse of 81 over 63. It's about an angle of elevation of about 52.1 degrees for three significant figures. All right, I have one more I wanted to show you here. It's the last one. It was on the IB exam last year. And it says that we've got a sailing boat in the shape of a right triangle, ABC. BC is 5.545 meters, CAB 76 degrees, and ABC is 90 degrees. Calculate AC, the height of the sail. All right. So this is sine, cosine, tangent. From that 76 degrees, the 5.45 is the opposite side. And the x, the thing we're trying to find, is the hypotenuse. So to calculate the value of AC, we're going to use sine. We're going to say sine of 76 degrees equals opposite divided by the hypotenuse, which we can just call AC or x or whatever you want to call it. Now there's a little trick in algebra here. You can exchange the entire left side with the entire denominator, and we can set it up to say AC equals 5.45 divided by sine of 76 degrees. So I'll just go ahead and type that in the calculator. And the the hypotenuse of that triangle is about 5.62 meters. So that's part A. Part B says, okay, we've got another sailing boat, and it's in the shape of a right triangle as well. This time the triangle is TRS, where side RS is 2.8, and the area of the triangle is 10.7 meters squared. We're supposed to calculate RT, the height. And the easiest way to approach this is to remember that the area of a triangle is base times height divided by 2. We know some of these things. We know that the area is 10.7. We know that the base is 2.8. We don't know the height. We're going to call it x. And we know that it's divided by 2. So we're just going to solve this for x. 2.8 divided by 2 is 1.4, so if I just divide both sides by 1.4, then I'm going to be able to solve for x here. So 10.7 divided by 1.4 is 7.64 meters. That would be the height of the sail. And then we're supposed to calculate RST, the size of angle RST, which is, it's always the middle one. It's this one right here, so I'm going to call it theta. So now I know that this is 7.64. From theta, I've got the adjacent side and the opposite side, so I'm going to use tangent to solve this. I'm going to say tangent of theta is 7.64 over 2.8, opposite over adjacent. So theta must be the tangent inverse of 7.64 over 2.8. And we'll let the calculator figure out what that is exactly. Tangent inverse 7.64 divided by 2.8. The size of that angle is, to three significant figures, 69.9 degrees. Alright, so that's it. Thanks for watching. We'll see you next time for the law of sines and law of cosines.